Do you know how to apply the loading conditions obtained from a CFD analysis to a structural analysis? This job is tricky, but we make it very easy with Python scripting in Abaqus. So, stay with us to find out how.
What will you learn in this package? In this package, we first study the reason why we need to transfer loads from a CFD analysis to a structural model. Then I will explain about Python script and its use in Abaqus. In the next step, we will review the prerequisites for using Python script and also its flowchart. And also, we will review the script line by line. Finally, in the last step, we will learn how to create a plugin to transfer loads. Finite element analysis, or FEA, is a powerful tool for predicting the behavior of structures under different loading conditions. FEA allows the simulation of various types of loading, such as force, pressure, and temperature. Applying these load conditions accurately is crucial for obtaining reliable simulation results and designing safe structures. In some cases, the loading conditions may be obtained from another analysis, such as computational fluid dynamics, or CFD, and they need to be transferred to the structural model for analysis. However, during this transfer, the loads may not be applied properly to the model, especially when the loads are complex, such as the pressure distribution of a spacecraft or an airplane. Incorrect load transfer can lead to inaccurate simulation results, which leads to unsafe design. To solve this problem, a Python script has been developed to transfer the loads correctly to the structural model. This script ensures that the loading conditions are applied accurately to the model, even for complex loading profiles. The loads that are obtained from CFD analysis have their own coordinate according to the CFD model. Therefore, when a structural analysis has to be performed on the model in another software such as Abaqus, the meshing will be different and the node location may not be the same as the CFD model. Hence, this script is used to manage the loads and transfer them properly according to the structural model. By using this script, engineers can have more confidence in the validity of the simulation results and the safety of their designs. Applying the loading conditions accurately is very important for obtaining reliable simulation results and designing safe structures. What is Python script? Python is a powerful and object-oriented programming language that is widely used by software applications. Abaqus software also extensively uses Python language. To use Python in Abaqus software, we need to use Python scripts. Python scripts let you accomplish tasks in Abaqus that would be time-consuming or practically impossible in the GUI. Using a script, you can automate a repetitive task, vary the parameters of a simulation as part of an optimization study, extract information from large output databases, and even create user interface that customize the Abaqus interface. Well, now we are going to review the Python script used in the tutorial line by line. But before that, we need to check the prerequisites for running this script. As you know, we are going to transfer the loads that obtained from CFD analysis to structural model with this script. For this reason, we need the loads obtained from a CFD analysis and the coordinates of where these loads are applied. To do this, we need to get this information from the CFD model in the form of a CSV file. We will use this file in the script. Also, for the analysis in Abaqus software, we need a structural model and we have to create this model in Abaqus. We can use this model in two ways. Either this model is in the form of a CAE file or it is saved as an input file and called in the Python script. The created model in Abaqus has no loading, and the Python script will apply the loading to this model in Abaqus using the information of the CSV file. Before examining the script, it is better to review the flowchart related to it to understand its execution process better. At the beginning of the script, we have to enter all the required parameters, including the path of the structural model, the path of the directory where the new file is saved, and the structural model file format. In the next step, we have to check the format type of the structural model file. If the structural model file is the CAE type, we import the model using a set of commands. But if the file format is the INP type, we have to import it with different commands. In the next step, we have to enter the CSV file. Then we read the loads and the coordinates of the points that loads are applied to from the CSV file and save them in a list called flist. We also save all the nodes related to the structural model in a variable called iSet. In the next step, we create a counter called I and set its initial value to 0. This variable indicates the number of loads that have been checked and transferred. Now we have to check the loads that we obtained from the CSV file one by one. If the number of checked loads is less than I, we must get the value of D first. D is the distance between the structural model nodes and the coordinates of the location of the loads that we read from this CSV file. This means the closest structural model node to each coordinate in the CSV file will be selected as the new load location. Then a set is created for that node and the load is applied to that set. Next, we add 1 to I and repeat this cycle until all the loads are transferred and the script ends. Now let's go and check the code. In the Python script, we first have to write these imports. These imports should be written by default in any script that is used for Abaqus. We also import a math module to perform calculations. Here are the instructions for the model we need to create. The model should be created without loading. Meshing should be done, and then we need to create a set with a surface that will receive the load and name it load set. And finally, we save the model as an INP file with the name job1. Also, in the structural model, the name of the part before the assembly module should be part 1. And after the assembly module, it should be part 1.1. The format of the file containing the loads must be CSV, and we need to use Excel to convert a text file to CSV. In the CSV file, each line must have 6 parameters separated by commas. The first 3 parameters indicate the coordinates of the point to which the load is applied, and the next 3 parameters indicate the load magnitude in different directions. Therefore, in each line of the CSV file, the load and its coordinates are completely specified. In the next step, we need to get the required inputs from the user and save them in a list called A1. Path of the INP file, and here we enter the CSV file path. Then we enter the job name and part name according to the explanation I gave before. After a few moments, the model is created by the script. In this model, as you can see, the loading is applied to the sample. If we check the sets again, this time there are more sets. Actually, there is a set for each force that has been transferred. For example, let's check some of them. Here we can also see the forces that have been transferred. Now let's go to the job module and run this model. After a few moments, the job is completed and we can see the results. For example, you can see the stress. Also, displacement is visible in the sample. Well, now we intend to turn this script as a plugin. So let's go to in the plugin menu. Now we can enter the required information to start transferring the loads. Also, these files will be provided to you. You can use a plugin by copying them to this address. In this way, we were able to create a plugin for transferring loads from CFD analysis to Abaqus software.
Hello everybody and welcome to our new video training package of Abaqus. Script to transfer load from CFD. to structural model in Abaqus. This package includes these sections. Introduction. Lesson, Python script description workshop.